Hey folks, today we're going to register or sign up for one of my favorite websites. It's repl.it, repl.it. We're going to use this website to do some computer programming. Today we're going to be working with R, the statistical software that is used by many universities and many businesses around the world. It's very popular software. It's free, it's open source. Anybody can download it and install it on their own machine, or we can use it in the cloud. And that's where we're going to do it today at Replit. So we go to repl.it and enter. Now, one of the reasons I like this website so much is because not only can we code in R, but we can write code in other languages, and we may be writing code in other languages in this class, including Python, maybe even a little HTML. A little bit of computer programming is very helpful for statistics. Now, in order for you to get your Replit account set up, you're going to go click on the Sign Up button. And when you do, you're then going to go ahead and click on the G button, and you're going to sign in using your school @Learn account. Now, if for some reason you click on that G and that account is not in there, you're going to need to sign into your school account and choose that account. Okay, so I'm going to go ahead and click on it, but I'm already registered. I already signed up, so it's just going to take me to my account. Now, once I get into my account, what we're going to do is I'd like you guys to go and I'd like you to create an R program. The R program is going to look, well, first of all, let's go ahead and figure out how to do that. To start a new program in any programming language at Replit, you will go and click on the button that says New REPL. Now, from time to time, this software changes, and the button's been over here sometimes, and sometimes it's other places. In this case, it looks like it's here. It might even work if I click there, but we're going to click on plus new REPL. And when we do, we get a choice of different languages. And for me, R is up at the top of the list because I've searched before. But for you, you may have to scroll down until you find it, or you could simply just click here and type R, and then we get a million, oh, maybe R and then space. There we go. And then if you do that, then I think you get close. You get to R more quickly. But worst case scenario, you will just scroll down until you find R, and it looks like it looked like it was somewhere near the bottom of the list, but I can't see it there now. Let's see if we can find it. All kinds of fun programming languages. And where are you? R, where are you? Oh, well, anyways, you're going to try R and then space, and my hope is that'll get you to R pretty quickly. So you'll select R, and then you'll give a name to your first program, and you can call it whatever you want, first try. Today we're going to do stem plots and histograms, so you could call it stem plots or histograms. How about stem and hist? Ooh. Now, we may be doing each one in a separate program, but that'd be a good way to start. And then we'll go ahead and do create REPL. So yay, we're in there. We're almost ready to start coding. I don't know about you, but I'm pretty excited. For our first R program, it's going to be very simple, and we're going to get some benefits from doing this. In the old days, I would have students type all these numbers into their graphing calculator, and it's a little bit easier to type with your computer. So one of the things you're going to do is you're going to gather some data, and this data comes from page 47 in your Stats in Your World textbook. It is in problem number 1 under Do the Math. Anyways, that's where you'll get these numbers from. And you're going to go ahead and type them in just like you see here. You'll type the word passes because that's what the data is. And then you'll use the equal sign. And then open parentheses, comma between all the numbers, and then close parentheses. One other thing is you're going to need a little lowercase c right at the beginning of all those numbers. That is a convention that R follows that tells R that we're going to take all of these numbers and we're going to put them into something called a variable, and the variable is called passes. Now, you know about variables from algebra class. In algebra class, we'd have variables like x, and we might say x equals 7, and then you know about variables like y, and it might be equal to 3. And certainly know how to multiply things. Multiplying in R is a little different. In R, to multiply, we would say X, and then we would put an asterisk symbol, and then Y. And supposedly that should get us the result if we wanted to multiply X times Y. Now, I'm not entirely sure that's going to show up without doing a print command. So I'm going to go ahead and say print X times Y. And let's see what happens. So run. So 21 is the result. Yay, that actually worked. So 7 times 3. So anyways, in computer programming languages, we have variables, and variables are things that can hold information. And in this case, x held the number 7 and y held the number 3. But because we're super fancy statistics students, we are dealing with variables that can hold more than one number. That's new to us. In this case, we're going to hold all of these numbers, and the way that we tell R that we'd like all of those numbers to be stored in passes is we put a little lowercase c at the beginning of the list. Now, what we'd like to do is we'd like to have R help us do some stuff. Sometimes R will do calculations, and sometimes it'll do graphing. Now, the thing that we'd like to do here is we'd like to do a stem and leaf plot. And if you go to try to do a stem and leaf plot by hand, you'll see it's hard work. And unfortunately, our handheld graphing calculators, like this baby here, it's a wonderful calculator and I love it. And if you're going to take the SAT, you should have one. But it doesn't do stem and leaf plots, and that's okay. Anyways, we're going to get our software to do it for us. And the way we do it is just STEM. It's that straightforward. It's that easy. And then we just tell STEM to do something with passes. And that's it. So passes is known as the argument, and STEM with these parentheses is known as a function. And all I'm doing is I'm passing this argument passes into STEM. Now, in programming, I could put a variable in as my argument for this function, or I could have just listed all the numbers in there. But in programming, one of the conventions that we establish is we tend to like to store things in variables and then do operations on the variables. So for right now, we're just gonna store all the numbers in passes and then run the STEM function on passes. Now, when we run it, by pressing this button, we'll get the results over here. Now, for some things in R, when we run it, we're going to get the results over here. But for now, we'll get the results over here. Here we go. So 3, 2, 1, run. And there's the result. And there's our stem and leaf plot. Now, the only problem is that stem and leaf plot doesn't look exactly like what we would have done if we would have written this out by hand. So there are some things we can do to modify the look of the stem and leaf plot. And one of the things that we can do is this. We can put in something called scale. And we can set the scale to various values. If we just set it to 1, I believe it's not going to change how the stem and leaf plot looks at all. Let's try it. So here we go. 3, 2, 1, run. And it looks about the same. So I'm going to go ahead and change that number to 2. And then I'm going to go 3, 2, 1, run. And what we can see is it kind of spread things out a bit. So now the stems go up by 1 instead of going up by 2 like they did when I had a scale of 1. This is just something you have to play around with to get a feel for it. Now, there are times when we'd like the data. Now, by the way, when we spread the data out, it does help us to better visualize what's going on sometimes. One of the things we'll play around with stem plots and later histograms is that depending on how much we stretch the data out or smush it together, sometimes we get a better feeling for what's happening with the data. In this case, it's a little more clear that most of our data points are in the 34 stem area, or the 340 some number of passes. So that is kind of helpful to be able to change that scale. Now, we can also make it so we can squish the data together even more, and we could even put in, instead of a 1 or a 2, you could put in a 0.5, and then we mush the data together even more, and that's not necessarily that desirable. I can tell that, all this tells me is that I've had a lot of passes in the 300s, and I kind of already guessed that. So I think we're going to go with the 2 because I believe it's going to be more useful. There we go. Now, the other thing I wanted to show you is how to use R to graph a histogram. So I'm going to go ahead and I'm going to do the command for histogram. And again, like the stem and leaf plot, it's a simple command. It's just hist. And I'm going to go ahead and pass passes as an argument to histogram. And then if I run, I will get the stem and leaf plot over here. And over here, I will get a PDF that has a histogram graph of the data. So I'm going to go ahead and run this. So I'm going to go ahead and do 3, 2, 1, run. And again, the stem and leaf plot was plotted over here. And over here, a PDF appears that's called R plots. And that should be where our histogram is. So I'm going to go ahead and click on it, and the histogram will appear right over here. And what we can see is that when you're looking at the histogram of the data, it looks very similar to the stem plot, and that is not an accident. That is the way it's supposed to be. Now, the difference is that the stem plot is sort of these numbers here, the 30 through 37, they are going vertically. But if we moved those numbers down here, the 30 through 37, if we wrote them down here, or in other words, if we tilted the stem and leaf plot, there we go, like this, if we tilt it over so that the 30 is on the left and the 37 is on the right, we would see that this guy has a similar shape to this histogram. In fact, it's exactly the same shape. And I want to point something out to you. Notice that there's actually 3 pieces of data in this top row. There is a 302, a 304, and a 308. That's 3 pieces of data that are in that top row. If we take a look over here, in this bar, in this range right here, whatever that is, we can see that there's 1, 2, 3. The bar goes 3 up, and that 3 represents the 3 values that are in this range. Then, if we look at this bar on this end, it only goes up to 1, and the reason for that is because we only have 1 piece of data on this end. And you'll notice this very tall set of leaves that goes with this stem. This represents 1, 2, 3, 4, 5, 6 data points, including 341 all the way to 347. And if we look here at this tall bar, it goes up to 6. So the stem and leaf and the histogram are really they're basically the same thing. And doing the stem and leaf is a good way to better understand histograms, because histograms are always the count of whatever you're looking at neatly stacked one upon another, just like these digits are. So if this guy is 1 down here, this guy that's 6 should be exactly 6 times as high. And this guy that's 2 should be exactly twice as high. And this guy that's 3 should be exactly 3 times as high as the 1. Okay, so histogram bars are always they're almost like inches on a ruler. Okay, each inch is measured out the exact same distance. Now, just like the stem and leaf plot, sometimes we want to look at the histogram so that the bars contain more information, or they contain less information. And so what we do is we either expand or shrink the size of the bars. And there's several names that we have for the width of those bars. Sometimes we call them bins, and sometimes if you go to Google Sheets, they're called buckets. And then also they are referred to as a class, or they are referred to as the width of a class. This is the class width. Okay, so and also intervals. There's a number of different ways to refer to the width of bars in a histogram. And the reason why we care about the width of the bars in a histogram is because the width of the bar tells you how many data points you're going to have in any given bar. All right, so there are ways to change the size of the width in R, and the way we'll do that, sort of like with stem and leaf plots, we could put in scale. With a histogram, we're going to put in breaks. And if I put in breaks equals 3, and I run this baby, what we'll see is when I go to look at my histogram, I get 1, 2, 3 breaks in between my bars. Okay, 1, 2, 3. The breaks are the lines between the bars. Now, in other software like Google Sheets, we'll be more concerned with the actual width of the bins, and in the case of R, we're concerned about how many breaks we have between bars. So I'm going to go ahead and change this to another number. Let's go ahead and get rid of this, and we'll try a different one. So now I'll go ahead and put in 7 breaks, or maybe let's put in 9 just for fun. And then we'll run and we'll take a look at the histogram. And when we do, now we can see we have many more bars. And again, sometimes we like to have a larger width and sometimes a smaller width. And the picture changes, and as the picture changes, sometimes we get a better idea of what's going on in the data. In this particular case, we can see from the stem and leaf plot that there are 2 peaks in the data, one by the 30 and one by the 34. And when we're looking at the histogram, same thing. We see a peak near the 340 and a peak near the 300. Anyways, this is a good introduction to using Replit with R for stem plots and histograms. We will use Replit for more things in the future, and in fact, you are going to begin on an adventure very soon. I hope this is helpful to you.